Right, I think we're set up. So, hello.
Testing 1, 2, 3.
Oh, just mute you. Right, so welcome to my first OneLoneCoder.com live stream. When I started this channel back in January, I set myself a little challenge of trying to get one video out, say once a week, about coding. And my goal for the year was to get about 50 subscribers, and it turns out that so far we've hit about 500. In fact, we hit 511, which is a bit of a geeky programming number, and I thought a good enough number to have a little celebration with. And to be frank, it's also to test the YouTube streaming environment. I can see we're getting some people in chat already. That's good, so I'm not talking to empty rooms. Now, I've promoted this as programming the matrix, and I'm sure some of you have already worked out that means we're going to emulate sort of the matrix rain effect. And I thought it would be perhaps foolish to try and do this in real time. And I'm going to use the OneLoneCoder console game engine, which has been used in a lot of my videos. And it's a nice challenge because it's not too long, it's not too complicated. It means I can use this as a video in its own right when we upload it. So I think we'll start by trying to get through the main video, and then if there's any time at the end, or if anybody's still around, maybe ask a few questions and hang around in chat. So, let's get started. So, I've got my Visual Studio environment here, and I've created an empty blank main project as normal, and I've included the console game engine. And whenever we use the console game engine, we need to override it. So we need to create a base class, which in this case I'm going to call Matrix Rain, and it's going to inherit from the game engine. And of course, if we create a class, the first thing we're going to need to create is a constructor for that class. Now, the worrying thing about doing all this live, of course, is you're going to see my typos and all the things that I edit out of the videos. Now, occasionally I'll try and glance at chat. This engine is impossible to set up in code blocks. Well, some people have managed so far. So if you've got a problem, have a look on some of the comments on the other videos. Now, one of the things we'll need to override first is the onUser create function. So let's do that. And that returns a Boolean onUser create. And we'll just get it to return true to start with. So we're just doing the very basic little bit of boilerplate that's required to get up and running. And onUser update takes, of course, f elapsed time. Now, one of the things I'll have to try and get used to is making sure the code is in the middle of the screen. And this also will make return true. So what is it specifically about code blocks that makes this tricky to run? In our main function, we'll create an instance of our Matrix Rain class. Let's call it Matrix Rain demo, and we're going to create a console, construct console, that's the function, and the dimensions of that are going to be, I've got some little notes here, but I've not actually seen what the end results look like, so that's why I'm a little bit more nervous than perhaps I should be. So it's 128 wide by 80, and each character is going to be 12 by 12 pixels, and we'll start. And that's all we need in our int main. So how are we going to tackle the matrix rain problem? Well, I know that it means we've got basically strings of text dripping from the screen vertically. And strings of text are good because we've got character arrays. We can do that in programming quite simply. We want them to drop at varying speeds, I think, and we want them to look just about right. So I think the first thing I'm going to do is create a struct called a streamer. And this struct is going to represent the string that's being displayed and its position on the screen. So I'll create a private struct, and we'll call it sStreamer. And I know that my screen is split into rows and columns, so we'll attach the streamer to a column. We'll have integer for that, and we'll call that nColumn first typo, end column, and we'll default it to 0. So the column is going to be basically our x coordinate on the screen. Hey, thanks, Keek. That's a very nice thing to say. Maybe use code from Frogger. Well, I know somebody who had difficulty getting Frogger started because they also didn't download the sprite pack that was necessary, which is also on the GitHub to download. So they just basically got a load of pink gibberish on the screen. I was quite worried about it at first until then I forgot to download the sprite pack on my testing machine and then fully understood their frustrations. Right, so we have our x-coordinate, which is going to be the column, and we're going to need some text, and we'll store it as a string, or w-string in this case. Let's leave it at that for now. Oh no, we're also going to need where it is on the y-axis, so which row is it going to be. And because we're going to be running things at very high frame rates, and as usual I want things to be smooth, and you may have seen in the last few videos we talked about every elapsed time, I'm going to use a floating point value to store the y position of the string. And we'll also default that to 0. We know we're going to have more than one streamer, so I'm going to store these streamers in a list. And we'll get to some of the fun stuff when we start running it, but we need to get the basics up and running first. So I'm going to use a list from the standard library, and it's going to store a streamer. And we'll call it list streamers. Now, make sure I'm using, I'm using the namespace standard. That's good. And so on my onUserCreate function, I'm going to try and populate this list. With lots of streamers. So let's go through n equals 0. N is less than the max number of streamers that I'm going to have. So I'll have to create a variable for that, but I'll call it max streamers for now. N++. So with our list, let's also store n max streamers. And for now I'm going to set that to 1, so we've got control over what's going on. And for each streamer that I want to store in the list, I'm going to create the object of it. Yes, streamer. Let's put in a capital S there. Streamer S. And we're going to push it onto the list. So I'm going to push 200 streamer objects onto my list. One thing that doing these videos has taught me is it's very difficult to talk and code at the same time. And of course that is now list streamers. Let's get it right. Dot push back. So I've created a linked list and I'm going to push back into that the number of streams that we're going to have on the screen. And of course they all default to 0, 0. That's what we set up before. Let's have a look at our drawing routine. So onUserUpdate is the frame update. Hang on, this is the first time this has happened, so let me have a look. It says this message is held for review. This streamers.pushback JavidX9. I guess that's semantically correct. Yeah, I don't know why YouTube flagged that for spam though, but hey. Right, so on our drawing routine, we want to black out the screen first, so we don't want to draw the random memory and gibberish that we'll see in the background. So to do this, we just simply take our x-coordinate, which is the top left, and our y-coordinate, and we're going to draw it to the full size of the screen. Screen width, screen height, and we're going to draw well, we want to draw it all black, don't we? So we're going to use a solid pixel, which is pixel solid, and want to draw it with a black colour. You may have seen in some other videos I simply draw a space character. That pretty much does the same thing. And then for each of the streamers we're going to draw them, and I'm going to use a little for loop with an auto keyword to scroll through, well, to iterate through our list of streamers. So let's just make sure we're at a point where everything can kind of compile. Make sure I'm in debug mode here. taking its time, it's having a think. Okay, good. So we're seeing just a black screen updating at, well, on my screen here it says about 2,800 frames per second. That's because it's not doing anything. I wouldn't expect it to. I would expect it to drop when we start drawing things. So, what are we going to draw? Currently we've got our variable text, but we've not set it to anything anywhere. I'm going to create a function which allows us to specify what the streamer contains. So I'm going to create the function called preparStreamer. Because I know that when we're done with a streamer, once it's fallen off the screen, we're probably going to want to reset it. We don't want to remove the object from the linked list. We can just change its properties and reuse it. So that will take in a pointer to streamer s. I don't mind puns. I'm quite happy with puns. I tried to press Shift and Enter and it didn't work. Well, press harder. I don't know. Shift and Enter. Right, so when we're creating our streams in the onUserCreate, this is where we're going to prepare them. So we'll also call our preparStreamer function, and all we need to do is pass in the address to the streamer. Now it just makes me think that's my first bug, because of course we don't want to pass in the address because that's already expecting a reference. We're going to pass in a pointer. There we go, that's better. That makes more sense. And so to prepare the streamer, I'm just going to simply set the text for that one to something that we know. So let's start with A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. The alphabet. And the reason I want to use data that I know, such as the alphabet, rather than just random characters, is because I'll be able to see if anything's going wrong when I'm displaying it. Right. So I'm just reading the chat here. I tried to press Shift and Enter and it didn't work. No, I don't get it. Sorry. So once we've got a streamer, let's work out how we're going to display it on the screen. So we've got our loop going through them, and we know that rather than just using the drawString function, because that will draw things horizontally, we want to do it vertically instead, and that's where things get a little bit more interesting. So we can iterate through each character in our string and draw them on successive rows across the screen. So let's create another for loop for this streamer, which is going to iterate through all of the characters in the streamer's text. s.stext.size. And so for each character, we can use the index I that we've just created to index both the string to get the character's position and offset it on the screen. So let's have a look how we would do this. So we can use our draw command because we know that that draws characters in essence, and we want to set this to the column that we've got in our streamer because that represents our x coordinate. And for the y, well, we know that this is currently a floating point, so I'm going to cast that to an integer. It's a bit quick and dirty, but hey, we'll live with it for now. So that becomes f position, so that's our x and our y coordinate. Now our y coordinate is also influenced by this I variable because that's what's going to change the row as it's going down the screen. So I'm also going to take away from the y position the I coordinate. So we can see that the f position is going to be the head of the stream and everything else is going to follow it. So we've got our x and our y, and now we'll choose the character as well. So that can be just s.stext, and we can use the array notation to access the character because it's a W string. I. And finally, for the colour, well, let's just say for now, let's just say it's white, whilst we're debugging what this is going to look like. So we're just drawing to our x coordinate, the y coordinate which is offset by the row and the current position of the streamer, the character of the text for that row, and we've set the colour. We probably also actually want the streamer to move, so let's update the speed. We'll do this in our auto loop. So this is s.fPosition plus equals a speed, I don't know, let's say 10 times f elapsed time, of course. Right, let's have a look what happens here. So I'm expecting we should see the alphabet move down the screen on the left. Oh, there we go. So A, B, C, D, E, F, G, all the way to Z, and it gets to the bottom. We can see it falling down. Right. Good. I think we need a few more of them. So let's set our max streamers now to 200. And we probably also don't want them all to appear at column 0, we want them to be all over the screen. So in our prepare streamer function, I'm going to choose a random value. And the random value is simply going to use the rand function. Rand modulus, wrong one, modulus the screen width. So we're picking a random number between 0 and the screen width. Right, let's have a look now. Okay, lots of alphabets falling down the screen. Whilst I'm here, I'm also going to set the other values as well. So we know that our f position is probably always needed to be 0. When we reset it once it falls off the screen, we want it to cycle back round. In fact, I'll do that now. So whilst the streamer is being drawn, after we've drawn it, we can check, is it still on the screen? Am I planning on adding FPS regulation functions to the engine? No, but it's not a difficult modification to make for yourself. The trick is, what do you want to do with the time in the background? Do you actually want to update game logic and then just chip in, say, every 60 Hz to update the screen? It's not too difficult to do, because in your update loop you can simply accumulate time. And so if you accumulate more time than, say, 1 over 60, on that 1 over 60 instance is when you would update the screen. So you can keep doing the game logic in the background. So it's not too difficult to do. And people, well, I say people, I know somebody has thought about something similar for the Snake game, which used an artificial delay in it. And when they tried to port that over, it was quite tricky. And because it simply delayed the thread, so all of the user inputs would stop because they were using the on-user update function. However, moving it to this way where it ticks after a particular time has passed, that way all of the inputs were accumulated, everything was accurate, the game was updated at high speed, but it was only drawn at, I think it was a very low frequency for Snake, wasn't it? It was only something like 5 Hz to give you that sort of chunk, 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 chunk effect. Right, so where were we? We were drawing the streams and we wanted to check if they were going to fall off the bottom. Well, how can we check that a stream has fallen off the bottom and completely disappeared? Well, we've got the f position variable, if, so we can check on the f position variable. So if our f position is greater than or equal to screen height, we'll just call our prepare streamer function again for the particular one that we've got. And I think yep, that's a pointer, so I need to dereference that. Now this will make the streamer disappear as soon as it hits the bottom of the screen, and that's not quite what we want. We want the streamer's tail to end up off the screen before we reset it. So to do this, we just simply check for the end of the streamer, which of course is the front minus its length. So let's have another run. Let's see what happens. And what I'm hoping is when the whole thing has fallen off the bottom of the screen, we see it appear at the top. Fingers crossed. Very good. Nice. However, this is a bit of a boring matrix rain. I think we can start to break it up a little bit. I think the way to break it up first is to change the speed of some of the streamers. So we've got everything moving at 10 frames per second, and that doesn't quite happen in the matrix as I remember it. So let's do something about that. So for each streamer, I'm also going to store a speed value. We'll default it to something there, but we'll use our prepare streamer function to choose a speed. And I think we'll use the rand function again. fspeed equals rand. And I don't know what kind of speeds we want, but I know I want them to be greater than 0, because I want it to actually move, but I don't want them to be so slow nothing happens. So I'm going to pick a value, 40 plus 5. And I'm using the plus 5 to give it some velocity, because otherwise it may end up with some very slow movement, which wouldn't be very aesthetically pleasing. But now, of course, we've added the speed value to our struct. We need to, in our updating streamer function here, instead of having this hard-coded, we want to choose the speed value. fspeed. So, let's have a look at that. Right, very nice. So, it's very difficult to follow what's going on the screen, but nonetheless we're seeing raindrops scrolling down the screen with quite a nice distribution. So what's next? So, okay, now I have a little checklist to make sure I get through everything, because I don't want the video to just drag on with me thinking about the problem. Right, the next thing is, not all the streams should be the same length. But for now I'm going to leave the s-text to be something we can recognise, because one of the things about Matrix Rain, I'll just set this running again, is Matrix Rain isn't just discrete lumps of text falling down the screen. The text remains in place on the screen. It's a bit difficult to describe if you've not seen it. So whereas here we're seeing the letter A fall down always at the front, it isn't quite like that. The letter A would remain static in that position, and we would see the tail come up and overwrite it, and the head would be laying down new characters. So we'll try and emulate this effect, and this is a bit tricky. Hello, Matt. So how can we do this? Well, I'm going to pull up Notebook or OneNote. So we know that we're going to have a bit of an alphabet going down the screen. So if I draw just the first, say, characters of the alphabet. And I'm going to stop at H because conveniently that's 8. And we'll index these as well. We'll draw the index 0, 1, 2, 3, 4, 5, 6, and 7. At the moment we have a position which represents where the head is, where A is. That's our F position variable. So I'm going to assume that, say, it's 50 at this point. I need to calculate an offset into this string to make sure that it remains consistent. So as it's scrolling down the screen, it's a bit, like I say, it's a bit difficult to describe the effect, but I think hopefully the maths will show what I'm trying to achieve. So I want to create an index into the string to make sure that the letter A effectively stays in one place on the screen even though the streamer is scrolling down past it. Why the subscriber notification is using printf instead of cout. It's more old school. It's more what I'm used to than this, IO stream rubbish. That's for the millennial generation, isn't it? So to see half of my subscriber base disappear now. No, I just like printf. I like the fact that it's very classic. Printf, hello world. So I want to calculate an index here, and if I'm trying to calculate an index based upon my Y position, I need to do some sums. And the sums that I need to do are going to be the current I position, which is our index, minus the current Y position. I want to do that sum and take the modulus over the length of the string. And in this case, for this example, I've got 8. So, what do we know about the modulus function? Well, in this case, if I calculate this out, I'm going to get minus 50 mod 8, which is 6, remainder 2, so that's the result of our modulus. But we get this odd quirk using the C++ modulus that it actually uses the dividend sign to give us the result. So this will give us minus 6, remainder 2, which gives us an index of minus 2. And if we take this one up here now, so if we work our way backwards, we've got 1 take 50, modulus 8, which of course becomes minus 49, modulus 8 equals minus 6, remainder 1, yep, but in this case becomes minus 1, and what we'll see is we actually get this wrapping around, so it becomes minus 7, minus 6, minus 5, minus 4, minus 3. Why? I may surprise none of you have asked, but why are we doing this? Well, if we go down to the next line now, 51, and we know that the index has also moved down, i.e. the whole streamer has moved down, we can still do the calculation. 0 minus 51 mod 8 equals whatever would equal minus 6, remainder 3. And this is quite nice because that means even though our screen position has changed in the y-axis and our index through the string has changed, we're actually getting some consistency moving up and down the screen. And I will show you what the effect looks like. We'll code this in. So, let's calculate the index that we want to draw. We'll call it character index. Our index equals the position in the string that we want to draw, which particular letter, minus, and we're going to cast to an int the position, the y-coordinate of our streamer, and we're going to mod that with the length of the streamer. And so instead of just drawing I, we're going to draw the character index. Now, hopefully this will work, and we'll see why all of this might have been important. And good, it has worked. What we can see now is that the characters remain in the same place on the screen. And this is actually what happens on the matrix. If you look at this stuff on the matrix, the characters don't move. The tail overwrites with darkness, and the head sort of unfolds new letters as it's falling down the screen. So I feel that this is quite an important thing to try and replicate. But there's a little bit, and if you watch any EEV blog, sorry Dave Jones, there's a bit of a trap for new players here. Because we're potentially getting a negative sign going into our array. So when we're choosing the character, this nchar index is potentially negative, which of course is bad. So why isn't it just crashing all over the place? Well, so it keeps scrolling over here. Text.size here is of type size t, and size t is of type unsigned char. Sorry, no, it's not. It's unsigned int. And the modulus function is taking that as the dominant type to perform this operation. So even though this resolves to an integer, we're then doing modulus with an unsigned integer. So it's automatically unsigned integering this value. Even though we've not told it to do that, that's how it's being cast. So if this becomes -1 as a result, it's actually being calculated as 4,100 and whatever million it should be. So to make this extra safe and legitimate, what we should be doing is putting in the absolute value instead. And we can test the theory, because if we take back out the absolute value, and instead of using the unsigned int type, if we actually cast this to an integer, so now it's an integer modulus operation, oh dear, we get problems. So I'm going to be explicit in this case and actually put in the absolute keyword. Right, let's just double check that everything's okay. It's looking good. So far, things are moving at different speeds. I think we need to start thinking about colour. Well, of course, the matrix is very familiarly green. So we'll set a green colour to be the choice that we're drawing the text out at. Now, colours in the game engine are stored as shorts. And I'm not going to put it here, actually, I'm going to put it down here, because we're going to need to change the characters on a character by character basis to their colours. So we're going to choose a green, aren't we? Yes, FG green. And instead of using the draw command to draw white, we'll use the col. And the reason I've changed this to a variable is because I'm going to use a bit of an age-old trick to give a sense of depth to what's being displayed. Good, I'm glad we've got a crash counter on the go. So they'll soon be outnumbering the number of subscribers. Right, so instead of choosing just green, I'm going to, depending on the speed, choose a different shade of green. And my reasoning for this is, if it was really far away, we would see it moving slowly. And we can equate sort of far away with being a bit darker, perhaps. And of course, it does give the perception of moving slowly if things are further away. So we'll check based on f speed. If that's lower than, say, some small amount, then I'm going to set the colour to dark green. Else, use normal green. And I've used a ternary operator there. I know these have been proving divisive on some of the comments. However, this is a situation where they're very useful. So let's have a look. So we've got some of the slower moving ones looking darker, and the faster moving ones looking brighter. The matrix also needs to display the head of the stream as a brighter set of characters still. So perhaps we want to adjust our colour depending on the position of the index. So we know that 0 always represents the head of our streamer, so that should be white. So we'll change the colour simply to white. Else, it's in the body of the streamer. Now, the body of the streamer consists of green, which we know, except for the first few digits. They tend to look a slightly less shade of white, as if it's been sort of immediately appeared on the screen and it's settling down and changing to a green colour. So in that case, if I is less than 3, so the first couple of digits less than or equal to 3, then we're going to set the colour to grey. So it looks like it's fading into the green value. And of course we need some semicolons. Let's have a look. Right. Okay, it's starting to look a bit matrixy. However, the matrix didn't display the regular Western alphabet, and nor did it display everything of the same length. So I think we want to build a routine now which generates streams of different lengths with interesting characters. I'm going to need to choose random characters fairly regularly, I think, because we want them to change quite a bit. So I'm going to create a function to do just that. And I'm going to create that up here. So we'll choose, what should we do for random characters? wchar t? Yes, it is. wchar t. Of course it is. Random character. Make sure I spell that right. wchar, looking at, we need a typo counter. That's what we need. Right. and we want this to return some random value. Now, to start with, I'm going to keep it within the ASCII alphabet. So I think I've pulled up an ASCII table here. That's convenient, isn't it? Oh, good, nice. Yeah, I'm glad that people are turning up. It's good. And if we look at the ASCII table, what we can see is that the visible characters, i.e. not the control junk over here, but the visible characters start at number 33 and end at 126. And if I do my maths right, that's 93. So we want to choose a random number between 33 and 93. Good, we've got the typo counter. I think we're up to about 5 already. So let's choose a random number, and we want to cast it to wchar_t. And we'll just use rand. I know there's better random number generators out there, but we're just having a bit of fun. I think it might be inappropriate to have a full Mersenne twister implementation. What did I say it was? We wanted to start at 33, and we want to go to 93, don't we? So we want to choose a random number between 33 and 126. Sorry, that was it. Right. So that's going to return a random visible ASCII character. The crash counter's just crashed. That's about right for this channel. So instead of choosing the text now going through the alphabet, now that we've seen everything can render in the correct order and in the right place, albeit with some complex modulo arithmetic, we now want to create a stream of random characters. So to do this, I'm going to choose a stream length. So we'll just choose that randomly as well, streamer length. Just for those that don't know, there's a reason why I put N's and F's and things at the start of all my variables. It just keeps me in touch with what type it is. I'm sure somebody in the chat may be able to point out that that's called something, and I can't remember what it's called. It's something like Hungarian notation or something like that. It's not as popular now as it used to be, but I find it very convenient, particularly if you're working with hundreds of variables. It just gives you an idea, oh yeah, that's an int, it's 32 bits, it's signed or not, or whatever. So we want to choose a random streamer length, and for that I'm just going to use rand, and again I don't want streams of length 0, I want them to be at least something, so we'll say 10 as a minimum, and I don't know, something like 80 as a maximum. So that'll give us a 10 to 90 random number. Now I've got a length. Question, I come from scripting languages, so I'd like to ask, what's the difference between the arrow symbol and the point? Well, the arrow symbol is usually used when the variable is itself a pointer. So in this case, we're bringing streamer in as a pointer. Instead, I could choose not to. So where do we actually create a streamer? Let's say here. In this case, it's actually an object. It's not a streamer. And so the notation is simply, I use the point. I'm not working on a pointer variable. I'm working with the actual variable that represents that type. And that is all. That is the only difference between the arrows and the points. But because you're coming from a script... Was I right? It was Hungarian notation. Good. So because you're coming from a scripting background, and I don't know much about scripting backgrounds. I don't believe there are many scripting languages which sort of facilitate pointers in the same way. And a lot of languages do try to just get around it and treat them as if they're the same thing, like Java, where pretty much everything is a pointer. Yes, Hungarian. No, I'm glad I got that right. I did learn something at university. Right. Where are we up to? Oh, keep getting sidetracked. We were doing creating random lengths of characters. Right, so I want to create another little for loop, which we're going to iterate through for this stream length. And I'm going to choose a random character because I've created a function called random character. Where is it? There it is, somewhere. And we're going to append it to the string. stext dot append. So here we go. This is a good example. Here we've got s, which is a pointer to the object streamer. So we're using the arrow notation. But once we've got the arrow notation, that's returning not a pointer. It's returning the actual object. So we can use a point to get the next property. What are you coding exactly? I'm coding the matrix rain effect. I guess one of the things I didn't want to start by showing that here we've got some matrix rain. Because you'd all see, oh, it's matrix rain, and then you'll just wait for me to upload the source code. So it's a way of if you've just joined the stream, we're sort of in the middle of a fiddly bit. Yeah, many of them don't. I'm a JavaScript and PHP dev, and they use to access object methods properties respectively. Really, I didn't know that. That would be very confusing if I came to that language and they used those symbols to mean different things. Isn't the rand function just returning a number between 1 and 0? And then wouldn't rand just return the value of rand? Wouldn't rand... no, in C++, the rand function returns an integer, usually in the range of rand and rand max, which is a constant defined somewhere in the bowels of the C language. I think it's the maximum value you can store in an integer. And as a consequence, if I did want to return a floating point, between 0 and 1, for example, I would do something like this. It looks a bit ugly. So what would it be? Rand max. Have to put some casting in there. So that would give me a value between 0 and 1. We'll just have a look at rand max. So it's 16-bit, not 32-bit in this case, that it's choosing a value from. So yes, in some languages random does return typically 0 to 1. I think Java's random does, doesn't it? And then it counters things. Yeah, that's okay, Joel. You know, it's all about the learning round here. Right. So we had a look at random numbers. S.text, we're going to append to it our random character. And so before we do any appending, I probably want to clear it. Actually, it's saying we're getting a little error here. What have I missed out? Oh, I want to append a single character. Silly me. And we want to clear the string first. Ugh, now I'm getting confused now. Dots and arrows. There we go. S.text. .clear. Oh, typo counter. Come on. So we're going to clear the string before we start appending characters to it, or else the string would just forever get longer and longer and longer every time it went around the screen. And we don't need this anymore. We're going to set it explicitly. Let's have a look. How are we getting random ASCII characters going down the screen? Yes, we are. And it's beginning to look a bit more matrixy because we're getting sort of jumbled up symbols and all sorts of things. I think I might add a few more streamers. It's looking a bit sparse. So, where did we set our stream count? There we are, max. Let's just have a 300, do you think? Maybe that's too many. Let's have a look. I quite like that. I quite like that. 300 it is. But the ASCII characters aren't usually what are used in the matrix either. It actually seems to be, to my ignorant eyes, looks like some sort of Japanese characters. Now, how do we get those? We know we've only got sort of ASCII to work with. Well, we've got Unicode, and we've got a lot more characters than perhaps you might think. And one way to find out what characters you've got are to pull up good old-fashioned character map. You know that thing that's been sat in accessories since day one of Windows, which you've never used? Well, we're using it now. And we know that the font that we use in the game engine is Consolus. And the nice thing about Character Map is we can click on a letter, and right down here in the bottom corner it displays the Unicode code point to represent that symbol. So let's go and find some more interesting symbols to draw. Ah, thanks, Construct. They use katakanas. Right, okay. Well, I don't think I've got a font which represents that. So I'm going to choose just what are the most weird looking symbols that we might want. Hang on, I've got lost. I want them to be almost recognisable as digits. I mean, this is, I'm trying not to be offensive. This is to my Western eyes. I'm sure these symbols are quite commonplace all over the world, just not here in the UK. So I'm going to pick... let's try you. 388. and we'll pick a bunch of you, 388 to 471, I don't know, it's a couple of hundred. So if we change this 93, well, we'll keep this one actually, because we know that that's returning ASCII. So let's get it to return something else. Oh right, hey, yes, yeah, TypeScript and Node.js. Well, you know, at least you've had a go. That's good to know. Instead, I'm going to choose. Oh, I've lost my point now. I'll tell you what, I'm going to go from the a note that I found from an interesting set of characters before, which is 1EF. So if we find that in here, 1EF, it's quite high up, and there was a reason that I think I wanted to do this. And some people might have experienced a problem with the console game engine on their systems. I know there's been a few people that just had no luck with it at all, and I've been wondering, has it been something to do with the character set that's installed on their machines? So I'm going to choose the character 0x1EF, and from that we want to get a whole bunch of them. We know that it starts off there. So we're choosing what is that? It's about 120 something characters, starting at position C0 in hex. Let's have a look. What characters are these? And there we go. So they're a little bit stranger, certainly to my eyes. And I think this is the point where I say, so there we have it. We've programmed the matrix in the command prompt. And it's not like some of these other dodgy matrix in the command prompt videos you've seen online either. I think this one actually looks quite good. So I'm not going to finish the stream just yet, but at this point I'm going to sort of finish off the video bit because I'll use this as a video as part of my regular output. So the source code will become available after I've finished here, and so if you've liked it, give it a thumbs up, have a think about subscribing. I'm going to stick around now and see if anybody's got any questions in the chat. Maybe they haven't. And thank you very much all for joining me on my 511th subscriber special. And just in case you're wondering why I quite like 511, I'm just going to pull a calculator onto the screen. It's a programming calculator, of course. If we go to decimal and type in 511, we can see that the binary is all ones. So I think it's good to have some sort of special whenever we hit all ones in my counter. So there you go. Thank you all for joining. I think it really looks okay. I think it looks like the Matrix. So I'm going to cut the stream. Oh, Timotech Server says hi. Hi, Timotech. Who have we had in here anyway? So, Robo Wicco, Jonathan Howard. Hi, John. Hi, Keek. Batin. If I'm pronouncing these wrong, I apologise. HDMI OK. Doing nice stuff. I like it. Thank you. It's good. Ah, DRAC. Ah, hello. Nice effect. Do you know, this was partly inspired by, I was reading one of your blog posts and you were looking for some code to display the matrix, or maybe I've misunderstood that. And Metrobug looks great. Thank you. I think it looks good too. Since you've talked about ASM in a video, will I do more videos about it? Yes, I probably will. Next year, I think the videos are going to be more focused on, well, maybe going down the embedded systems route. So I don't think ASM's going away. I'd also like to explore building an emulator and a virtual machine, which means we're going to have to look at some sort of a symbolic assembly language. Over already, such a shame. Well, I get some flack for my videos being a bit long, and given that this one I've been answering questions and things as well, when it goes up on the site, the people who aren't watching it now are going to see a video which suddenly says, well, it's an hour long or however long, and they won't watch it, which is a bit of a shame. I know my videos require that you sit down and watch them, and usually watch them in parts and then rewind and watch bits again. And you know, I'm really grateful that so many people do. I've been so surprised by the such incredible positive feedback, and the fact that the community have really got stuck in with helping debugging things, and they've been giving suggestions. So we had Breck Martin putting it all on the PlayStation Portable, and we've had people creating browser-based first-person shooters using similar algorithms. I've noticed a number of forks now on for the GitHub repository, so it's well exceeded what I was expecting. Thanks, Nick M. Thanks, AzertiUEOps7893. It would be good if you just choose names that are easy to say. Mori Noando. Over already, such a shame. Well, I might hang around in the chat for a bit, but I think that's probably it. So thank you for joining me on this subscriber special. Next stream, Coding Doom. Well, there's there's already a video. You can go and check out the rest of the channel. That one's been done. So thank you guys. I'm going to hang around in the chat for a little bit if anybody's interested, but I'm going to cut the stream now. So thank you very much. Good night.